Alrighty, so peace, kings and queens. So unfortunately, when I recorded the video the first time, something happened on my computer, and I don't know what happened. So I have all the notes here, and I'm just going to talk through them while you guys are copying. So if you look up here, it says your essential question is going to be, how do you use addition and subtraction and multiplication and division in order to solve inequality? So the first thing our definition says, an inequality is going to be an open sentence that contains a less than or greater than, less than or equal to, greater than or equal to sign. All right, so for instance, if I have 4 is less than 5, it's the same thing as saying, writing the symbol 4 is less than 5. Okay, the next thing that's up here, it says, I have the addition property of inequality. So it says if the same number is added to each side of a true inequality, the resulting inequality is going to be true. So for instance, if I look at this first part where it says if A is greater than B, the same thing is going to be true then if A plus C is greater than B plus C. Okay? Same difference if I have A is less than B, all right? My statement's still going to be true if I have A plus C is less than B plus C. Okay? And it's also going to work for less than or equal to and greater than or equal to. All right? So, if you need to pause it, go ahead because I know I'm going to talk kind of fast through this. Okay, so let's keep going. If we look at number one says solve the inequality x minus 12 is greater than or equal to 8. All right, so this, when I'm solving these problems, is just like solving equations. I have to isolate my variables. So if we look at the first step, all right, right here, all right, in order to get x by itself, I have to add 12 to both sides. So when I added 12, my new inequality said that I have x is greater than or equal to 20. So when I'm writing my answer, the answer is going to be the solution set. That means that's what my brackets are for. All of my numbers that are greater than or equal to 20. Okay? Also, when I'm talking about this stuff, I also have to make sure that I understand what it means to graph. So if I look at this bottom note that's down here, it says if the inequality is less than or greater than, all right, we use an open circle to graph the inequality on a number line. If the inequality is less than or equal to or greater than or equal to, we have to use a closed circle to graph. So looking back at example 1, my answer says greater than or equal to, so I'm going to have a closed circle. So when I'm graphing, I'm going to make a number line like I did here. So I have 20, all right, let's imagine 21, 22, and all that stuff is there and so on. All the numbers that are greater than 20 or equal to 20 are going to be graphed. So that's what my graph should look like. A closed circle and an arrow for everything greater than and equal to 20. All right, if I look at number 2 says 22 is greater than m minus 8. So just like my equation, to get m by itself, I have to add 8 to both sides. All right, so when I'm adding 8, I get 30 is greater than m. This time, anything that is less than 30, all right, but not including it is going to be graphed. So that's why I have an open circle and including everything that is less than 30. Okay. Let's keep moving. I know it's kind of fast. Let's go to page 2. All right, on page 2, I want you guys to try the first example. All right, and then we're going to talk about it in class tomorrow. But now let's look at the last part. The next part says if you multiply or divide each side of an inequality by a positive number, then the inequality remains true. That makes sense. But if you multiply or divide each side of an inequality by a negative number, then we have to change the direction of our inequality symbol. So let's think about it. If I have my example right here where it says 6 is greater than 3.5, okay? Let's say that I multiply it by 2. Well, 6 times 2 is going to be greater than 3.5 times 2. That's true. 12, which is 6 times 2, is greater than 3.5 times 2, which is 7. That's still true. All right, but if I do something a little different, let's look at 3 is less than 5. All right, and I want to multiply it by negative 4. Well, 3 times negative 4 is negative 12. Okay? But 5 times negative 4 is negative 20. Negative 12 less than negative 20 is false. Alright, so when that is the case, I have to switch the direction of my sign. So now negative 12 is greater than negative 20. If we think about it on the number line, negative 12 will be here, and then negative 20 will be somewhere over here. So negative 12 is the greater number. All right, negative 12 is the greater number. All right, if we keep going and look at number 1, all right, and it says solving graph, I have negative 3 over 7 times r is less than 21. All right, in order to get r by itself, I have to divide each one by negative 3 over 7. All right, when I do that, I should get r. I have to change my symbol because I'm dividing by a negative. All right, so r is going to be greater than 21 times 7 over negative 3. All right, to make this a little bit simpler, I just canceled out and made this a negative 1 and made this a 7. All right, so r is going to be greater than 49 over negative 1 because 7 times 7 is 49. Or we're just going to say that r is greater than negative 49. And that's what the graph should look like. Okay? And last but not least, let's look at the last problem. The last problem says negative 7d is less than or equal to 147. So I have to divide each side by negative 7. Okay? When I do that, since I'm dividing by a negative again, that sign is going to change. So d is going to be greater than or equal to negative 21. All right, I know I went through that really fast. We'll review that in class tomorrow. I want you guys to go ahead and graph number 2 and write your summary. Have a good evening.